Hello my dear students, welcome back to our channel Maths for All. This is Sudhakar Reddy. So in this video, we are going to discuss a very important chapter, very typical chapter and very interesting chapter in trigonometry, that is called inverse trigonometric functions. Inverse trigonometric functions, very important. So in this chapter, we are going to discuss the definitions and graphs of and so many things. Don't miss the video. Watch the video completely. If you didn't subscribe my channel, please do subscribe and click the bell symbol. So let's discuss the concepts and different graphs of inverse trigonometric functions. Right. So inverse trigonometric functions. So we have 6 trigonometric ratios, as you all know very well. Those are sine, cos, tan, cot, and secant, cosecant. So inverse of those trigonometric ratios. So if you want to discuss about this chapter, first of all, we have to know what is an inverse function. When a function has inverse, suppose a function f of x is said to have inverse. A function f of x is said to have inverse when this function is a bisective function. Bisective function. When a function is bisective, then only the function has inverse, otherwise it has no inverse. So bisective means a function f of x is said to be bisective if it is both 1 1 and onto. If it is both 1 1 and onto. Then what is 1 1 function? What is 1 1 function? A function f of x is said to be 1 1. A function f of x is said to be 1 1 if distinct elements in set A, that is a function f of x is defined from A to B, let us say. Here A is called the domain and B is called the codomain. So a function f of x is said to be 1 1 function if distinct elements in set A have distinct images in set B. Distinct images in set B. Distinct images in set B. So a function f of x is said to be 1 1 if distinct elements in set A have distinct images in set B. So when a function is f of x is said to be onto, a simple definition, a function f of x is said to be onto if codomain is equals to range. Of course, this is not a definition, it is a rule of onto function. A function f of x is said to be onto if codomain is equals to range. So a function f of x is said to be onto if codomain is equals to range. Suppose, for example, if you take the function f of x is equals to sine x. F of x is equals to sine x. Let us take the function f of x is equals to sine x. Generally, the domain of f of x, sine x is equal to R. Why? Because domain means the set of values for which the function f of x is defined. Domain means the set of values for which the function f of x is defined. So sine x is defined everywhere. Sine x is defined everywhere. Sine 0 defined, sine pi by 2 is defined, sine pi defined, sine 2 pi defined, sine 3 pi defined. So sine x is defined everywhere. So that the domain of sine x is R. And the range of sine x is equal to minus 1 to 1. Because the value of sine x lies in between minus 1 to plus 1. See, if you take the domain of sine x is R, suppose this is the domain and this is range. So let us say this is A and this is B. So here the domain is R. And the codomain is closed interval of minus 1 to 1 I have taken. Closed interval of minus 1 to 1 I have taken. Suppose in domain there is pi there, 2 pi there, pi by 2 is there, 3 pi by 2 is there, 3 pi is there, 5 pi by 2 is there, and so on. But in domain, minus 1 there, plus 1 there, in between minus 1 to plus 1, so many values are there. Of course, I have taken only 0. What is the value of sine pi? 0. What is the value of sine pi by 2? Plus 1. What is the value of sine 2 pi? 0. What is the value of sine 3 pi by 2? Minus 1. What is the value of sine 3 pi? 0. What is the value of sine 5 pi by 2? Plus 1, like this. Here, if you observe, here the pi and 2 pi and 3 pi and 4 pi have same image. What is the value of sine pi? 0. What is the value of sine 2 pi? 0. What is the value of sine 3 pi? 0. Here the pi, 2 pi, 3 pi have same images. But what the definition of 1 1 says? Distinct elements in set A have distinct images. So if you take the domain of sin x is R, that won't be 1, 1 function. If you take the domain of sin x is R, so then sin x never be 1, 1. If it is not 1, 1, it is not bisective, then it has no inverse. But the chapter is inverse trigonometric function. So that means if you want to have an inverse for the sin x function, we have to restrict the domain. We have to restrict the domain. So instead of R, I have to take the domain of sin x as, closed interval of minus pi by 2 comma plus pi by 2. Closed interval of minus pi by 2 comma plus pi by 2. So why we have to take the closed interval of domain as closed interval of minus pi by 2 comma plus pi by 2? Because in between minus pi by 2 to plus pi by 2, for each and every value of x, there is only one unique value of sin x. If x belongs to minus pi by 2 to plus pi by 2, in between, if you take any value in between minus pi by 2 to plus pi by 2, there exists only one unique value of sin x. Sir, why don't we take pi by 2 to 3 pi by 2, sir? Yes, that is also the domain you can take. In that domain also, so for each and every value of x, there exists only one unique value of sin x. Sir, why don't we take 3 pi by 2 to 5 pi by 2, sir? Yes, you have to take. But this minus pi by 2 to plus pi by 2 is called the principal domain of sine. Principal domain of sine. So, therefore, to make the sin x function as inverse function, we have to restrict the domain. Why we have to restrict? In the domain of R, sin x is not 1, 1. In the domain of minus pi by 2 to plus pi by 2, sin x function is 1, 1 function. If the range of sin x is closed interval of minus 1 to plus 1, then only the function is on 2. So therefore, if you take f of x is equals to sin x, then the function f defined from closed interval of minus pi by 2 to plus pi by 2 to closed interval of minus 1 comma plus 1. Whenever we take the domain of sin x is closed interval of minus pi by 2 comma pi by 2 and the codomain is closed interval of minus 1 comma plus 1. In this domain, sin x is 1, 1 and the range of this f of x is nothing but codomain of f of x. So range is equal to codomain. So therefore, the function f of x is 1, 1 and the function f of x is on 2. Therefore, the function f of x is equals to inverse bisection. Therefore, the function f of x has sine inverse. The function f of x has sine inverse in this particular domain and codomain. So if f maps from minus pi by 2 to plus pi by 2 to closed interval of minus 1 comma plus 1, then the inverse of f, it is usually denoted by f inverse, is defined from closed interval of minus 1 comma 1 to closed interval of minus pi by 2 comma plus pi by 2. The inverse of f is defined from closed interval of minus 1 comma 1 to closed interval of minus pi by 2 comma plus pi by 2, and it is denoted by sine inverse x or arc sine. Sine inverse x or arc sine x, both are same, sine inverse x or arc sine x. So what is the principal domain of sin x? Minus pi by 2 comma plus pi by 2. What is the range of sin x? Closed interval of minus 1 comma plus 1. So then what is the domain of sine inverse x? Very important. The domain of sine inverse x is closed interval of minus 1 comma plus 1 and the range of sine inverse x is closed interval of minus pi by 2 comma plus pi by 2. Very, very important. What is the principal domain of sin x? Minus pi by 2 to plus pi by 2. What is the range of sin x? Closed interval of minus 1 comma plus 1. So then for inverse, it may reverses. What is the domain of sine inverse x? Closed interval of minus 1 comma plus 1. What is the range of sine inverse x? Minus pi by 2 comma plus pi by 2. Minus pi by 2 comma plus pi by 2. Right. So if you see the graph of sine inverse x, the graph of sine inverse x is like this. First of all, let us see the graph of sine x. In this, I am going to draw the graph of sine x. So what is the principal domain? Principal domain of sine x? Minus pi by 2 to plus pi by 2. So domains are taken on x-axis. What is the range of sine x? Minus 1 to plus 1. Minus 1 to plus 1. This is 0. So this is the graph of sin x. This is the graph of sin x, y equal to sin x. If x is equal to minus pi by 2, sine of minus pi by 2, minus 1. If x is equal to 0, sine 0, 0. If x is equal to pi by 2, sine pi by 2, 1. So the graph of sin x is like this. The graph of sin x is like this, in between minus pi by 2 to plus pi by 2. In between minus pi by 2 to plus pi by 2, right? So in this range, if you draw the horizontal line, if you draw the horizontal line, then the horizontal line meets the graph of sin x at one and only one point. Then in that case, the function is said to be bisected. In that case, the function is said to be bisected. If the horizontal line meets a particular graph at only one and only one point, then the particular function is said to be bisected. Remember. So this is the graph of sin x in between minus pi by 2 to plus pi by 2. Now let us see the graph of sine inverse x. This is x-axis and this is y-axis. Now can you please tell me the domain of sine inverse x? Domain of sine inverse x. The domain of sine inverse x is minus 1 to plus 1. The domain of sine inverse x is minus 1 to plus 1. And the domain of, the range of sine inverse x is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Now I am going to draw the graph of sine inverse x. Y is equals to sine inverse x. So now sine inverse of minus 1. Sine inverse of minus 1, minus pi by 2, sine inverse of 0, 0, sine inverse of 1, pi by 2. Sine inverse of 1, pi by 2. The graph of sine x is like this. The graph of sine x is like this. This is the graph of sine x. Sorry, sine inverse x. This is the graph of sine x and this is the graph of sine inverse x. Remember? Very, very important. What is the domain of sine x? Minus pi by 2 to plus pi by 2. What is the domain of sine inverse x? Minus 1 to plus 1. What is the range of sin x? Minus 1 to plus 1. What is the range of sin inverse x? Minus pi by 2 to plus pi by 2. The graph of sin inverse x always lies in between minus pi by 2 to plus pi by 2. The graph of sin x is always lies in between minus 1 to plus 1. Very important. In a similar way, so we are going to restrict the domains of cos, tan, cot like this. So, sin inverse x. Domain, range. So the domain of sin inverse x is closed interval of minus 1 comma plus 1, range closed interval of minus pi by 2 comma plus pi by 2. In a similar way, cos inverse x, cos inverse x, cos inverse x domain is also minus 1 to plus 1. Why? Because the range of sin x is same as the range of cos x. So therefore, the domain of sin inverse x is same as domain of sin inverse x. But the principal domain of cos is 0 to pi. That's why the range of cos inverse x is 0 to pi. So if it is tan inverse x, domain R, any real number. But the range, open interval of minus pi by 2 comma plus pi by 2. Open interval of minus pi by 2 comma plus pi by 2. Cot inverse x, domain R, range, open interval of 0 comma pi. Open interval of 0 comma pi. Secant inverse x, domain minus infinity to minus 1, union 1 to infinity, range, closed interval of 0 comma pi minus singleton pi by 2, because secant function is not defined at pi by 2. So therefore, range in the range of secant inverse x, there is no pi by 2. So the cosecant inverse x, the domain is minus infinity to minus 1, union 1 to infinity. The range is closed interval of minus pi by 2 comma plus pi by 2 minus singleton. It's very easy to remember, The domain of sin inverse x and cos inverse x is same. The domain of tan inverse x and cot inverse x is same. The domain of secant inverse x and cosecant inverse x is same. But the ranges are different. If you remember the range of secant inverse x, so that is automatically equal to cosecant inverse x except 0. If you remember the range of cos inverse x, that is automatically equal to secant inverse x except minus pi by 2. Except pi by 2. Right. This is very, very important table. You must remember the domains and ranges of inverse trigonometric functions as well as trigonometric functions. Both are important. Now, let us see the graph of cos inverse x. Graph of cos inverse x. What is the principal domain? What is the domain of cos inverse x? The domain of cos inverse x is -1 to +1. The -1 to +1. What is the range of cos inverse x? 0 to pi, 0 to pi. In between 0 to pi, pi by 2 is there. Pi by 2 is there. Right. Cos inverse of -1. Cos inverse of -1 is pi. Cos inverse of 0 is pi by 2. Cos inverse of 0 is pi by 2. And cos inverse of 1 is 0. Cos inverse of 1 is 0. So the graph of cos inverse x is like this. The graph of cos inverse x is like this. This is the graph of cos inverse x. This is the graph of cos inverse x. Isn't it? This is the graph of cos inverse x. Cos inverse of -1 is pi. Cos inverse of 0 is pi by 2. Cos inverse 1 is pi. So that means the value of cos inverse x is always lies in between 0 to pi. 0 to pi. The value of graph of cos inverse x is always lies in between 0 to pi. Remember. Let us see the graph of tan inverse x. The graph of tan inverse x. Graph of tan inverse x. What is the domain of tan inverse x? -infinity to +infinity. -infinity to +infinity. What is the range of tan inverse x? -pi by 2 to +pi by 2. -pi by 2 to +pi by 2. At pi by 2 and -pi by 2, tan inverse is not defined. So whenever the function is not defined, we have to draw the dotted lines there to draw the graph. So tan inverse -pi by 2 not defined. Tan inverse 0, 0. Tan inverse infinity not defined. So tan inverse -infinity pi by 2. Tan inverse -infinity pi minus pi by 2. So the graph should be like this. Tan inverse 0, 0. Tan inverse infinity pi by 2. Tan inverse -infinity minus pi by 2. Tan inverse 0, 0. Tan inverse infinity pi by 2. So the graph should be like this. The graph of tan inverse is always lies between -pi by 2 to +pi by 2. This is the graph of tan inverse x. This is the graph of tan inverse x. Let us see the graph of cot inverse x. Graph of cot inverse x. Again, this is -infinity, this is +infinity, and the principal domain of cot is 0 to pi. 0 to pi. So in between 0 to pi, pi by 2 is there. In between 0 to pi, pi by 2 is there. At 0 and pi, cot inverse is not defined. So cot inverse -infinity minus cot inverse of -infinity minus pi. So cot inverse -infinity pi, cot inverse pi by 2 0, cot inverse infinity 0. Cot inverse infinity 0. So the graph should be like this. The graph of cot inverse x should be like this. This is the graph of cot inverse x. Like this, we can draw the graphs of secant inverse x and cosecant inverse x also. So now, let us discuss the properties of inverse trigonometric functions. First one, sine inverse of sine x is equal to x. Sine inverse of sine x is equals to x. Not for every x. So sine inverse of sine x is x. For all x belongs to, see here what is the inner function? Inner function is sine x, no? Inner function, what is the inner function? Sine x. What is the domain of sine x? So domain of sine x is -pi by 2 to pi by 2. So x belongs to closed interval of -pi by 2 comma +pi by 2. Here we are going to take the principal domain. So very, very important. In a similar way, cos inverse of cos x is equal to x. For all x belongs to, again, here the inner term is cos x. What is the principal domain of cos x? Closed interval of 0 comma pi. Closed interval of 0 comma pi. The third one, tan inverse of tan x. Tan inverse of tan x is equal to x. For all x belongs to, again the inner function is tan. What is the principal domain of tan? Open interval of minus pi by 2 comma plus pi by 2. Similarly, cot inverse of cot x is equal to x. For all x belongs to open interval of 0 comma pi. Secant inverse of secant x is equal to x. For all x belongs to closed interval of 0 comma pi minus singleton pi by 2. And cosecant inverse of cosec x is equal to x. For all x belongs to closed interval of minus pi by 2 comma plus pi by 2 minus singleton 0. This is the very first property in inverse trigonometric function. First, we have to observe the inner term, not outer term. So, sine inverse of sine x is equal to x. For all x belongs to domain of inner term. Inner term is sine x. X belongs to minus pi by 2 to pi by 2. Inner term is cos x principal domain. Inner term is tan x principal domain. Inner term is cot x principal domain. Secant x principal domain. Cosecant x is principal domain. This is very important. And let us see the second property. Second property, sine inverse x. Sine inverse x. Both are not same. Previous one and this one. Both are not same. Sine inverse x is equal to x. F inverse of f of x is x. F of f inverse of x. Both are same. But you must consider the domains. Sine inverse x is equal to x. For all x belongs to, what is the inner function here? Sine inverse x. The domain of sine inverse x is minus 1 to plus 1. Very, very important. Cos inverse x. Cos inverse x is equal to x. For all x belongs to closed interval of minus 1 comma plus, because inner function is cos inverse, domain of cos inverse is closed interval of minus 1 to plus 1. Tan inverse x. Tan inverse x is equal to x. For all x belongs to r minus infinity to plus infinity. Cot inverse x is equal to x. Again, for all x belongs to r. Secant inverse x is equal to x. For all x belongs to minus infinity to 1 minus 1 union 1 to infinity. Cosec inverse x is equal to x. For all x belongs to minus infinity to minus 1 union 1 to infinity. So the very first two properties, basic properties. Sine of sine inverse x, sine inverse of sine x. Sine of sine inverse x, sine inverse of sine x. Very, very important. Very, very important. So after the discussion of these two properties, we are going to discuss a very, 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 very important. That's the heart of inverse trigonometric functions, the graphs. We have already completed, no. That is a basics graph. Right. Graph of sine inverse of sine x. Graph of sine inverse of sine x. Graph of sine inverse of sine x. See, let y is equal to sine inverse of sine x. Let y is equals to sine inverse of sine x. Okay. From this, you can write sine y. Take the sine inverse to the side, sine y. So it is possible when this value lies in between the principal domain of sine. So sine y is equal to sine x. Sine y is equals to sine x. Sine y is equals to sine x. For all y belongs to closed interval of minus pi by 2 comma plus pi by 2. For all y belongs to closed interval of minus pi by 2 comma plus pi by 2. That is the principal domain of sine. So once revise the concepts of trigonometric equations. This of sine y equal to sine x It is of the form sin theta equal to sin alpha. If sin theta equal to sin alpha, the general solution for that is theta is equal to, here theta means general solution is y is equal to n pi plus minus 1 whole to the power of n into x for all n belongs to z. Y equal to n pi plus minus 1 whole to the power of n into x for all n belongs to z. Right. Okay. So if we take n equals to 0 here, if we take n equals to 0, then what will happen to this one? If we take n equals to 0, so y equal to x. Y equals to x. If we take n equal to 1, let us see what will happen. If we take n equal to 1, y is equals to n pi. N means 1, pi minus x. Pi minus x. If we take n equals to 2, then what will happen? Y is equals to 2 pi minus 1 whole square is plus x. If we take n equal to minus 1, so y is equals to minus pi, minus 1 whole power minus 1 is minus 1, so minus pi minus x. If we take n equal to minus 2, so y is equals to, it is minus 2 pi, minus 1 whole power minus 2 is plus 1 again, it is plus x. Like this, we may take so many values, 1, 2, 3, minus 1, minus 2, minus 3, like this. In all these cases, we get different lines. So y is equal to x is a straight line which is passing through horizon. So y equal to minus x, that's nothing but x plus y is equal to pi. It is of the form x by pi plus y by pi equal to 1. As x intercept is pi and y intercept is pi. That means this line intersect the x axis at pi and y axis at pi. And this is minus x plus y equal to 2 pi. Minus x plus y equals to 2 pi. And this is x plus y equal to minus pi. X plus y equal to minus y minus pi. This is minus x plus y equal to minus 2 pi. So in all these cases, we are getting the straight lines. So how to draw the graphs here? Let me explain. Okay. So do you remember all these lines? I am going to write here. The first one, when equals to 0, the line is like this: y equal to x. And the second one, y equal to pi minus x. Y equal to pi minus x. And the third one, y equal to 2 pi plus x. Y equal to 2 pi plus x. So y equal to minus pi minus x. Y equal to minus pi minus x. Y equal to minus 2 pi plus x. Y equal to minus 2 pi plus x. Okay. 0, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi. This is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, minus 5 pi by 2. So this is plus pi by 2. This is minus pi by 2. So the value of sin x is the sin in the graph of sin inverse x is always lies in between minus pi by 2 to plus pi by 2. The graph of sin inverse of sin x is always lies in between minus pi by 2 to plus pi by 2. Now we'll take the first interval, that is minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. So in between minus pi by 2 to plus pi by 2, so the graph of sin x is y equal to x. So y equal to x is a straight line passing through horizon. Y equal to x is a straight line passing through horizon. So this is the line y equal to x. Y equals to x. What is y? What is y? So sine inverse of sin x. Sine inverse of sin x. And what is the second line? This is y is equal to pi minus x. Listen carefully. Listen very carefully. So y is equal to pi minus x. Forget remaining things. Just remember this line. Y equal to pi minus x. Listen very carefully. Y equal to pi minus x. That is x plus y equal to pi, isn't it? x plus y equals to pi. That means this straight line intersect the x-axis at pi and y-axis at plus pi. This straight line intersect the x-axis at pi, y-axis at pi. So plus pi is there on x-axis and plus pi is there on y-axis. The straight line goes on like this. The straight line goes on like this. It intersects the y-axis at pi and x-axis at pi. So let us take the another interval period. So y equal to pi minus x, graph should be like this, like this, like this, like this. Is the graph. It intersect the x-axis. So this line is nothing but y equal to pi minus x. This is y equal to pi minus x. Y equal to pi minus x. Now, let us take this one. Y is equal to minus pi minus x. Y is equal to minus pi minus x. Y is equal to minus pi minus x. Right, like this. So take this one. This is minus x minus y is equal to plus pi. Am I correct? Minus x minus y. Take this plus pi to this side, minus pi to this side, and take this plus pi to this. So minus x minus y equal to pi. That means this straight line intersect the x-axis at minus pi, y-axis at minus pi. So both the intercepts are negative. So x-axis at minus pi and y-axis at minus pi. So this straight line goes like this. That straight line goes like this. That straight line goes like this. Because its straight line intersect the x-axis at minus pi and y-axis at minus pi. That straight line goes like this. So straight line should be like this. This one. So this is y is equal to minus pi minus x. Y is equal to minus pi minus x. Now lines are not required to me. Now the lines are not required to me. I have got an idea, right? So next line should be like this. No doubt about it. Next line should be like this. No doubt about it, right? Acha. So now this straight line intersect the x-axis at 2 pi and y-axis at 2 pi. This straight line intersect the x-axis at 2 pi and y-axis at negative y-axis minus 2 pi. This straight line intersect the x-axis at plus 2 pi, y-axis at minus 2 pi. So the equation of this line is x by 2 pi minus y by 2 pi equals to 1. Why? Because this line intersect the x-axis at 2 pi and y-axis at minus 2 pi. So the line equation is x by 2 pi minus y by 2 pi equal to 1. So x minus y equal to 2 pi. X minus y equal to 2 pi, isn't it? Acha. So from this y equal to how much? Y equal to x minus 2 pi. Y equal to x minus 2 pi. There it is. Isn't it? Y equal to x minus 2 pi. So this is y equal to x minus 2 pi. Now here the line should be like this, no doubt about it. The line should be like this. Understood? The line should be like this. So it goes on. It goes on. So it intersects the x-axis at minus 2 pi and y-axis at plus 2 pi. The line intersects the x-axis at minus 2 pi and y-axis at plus 2 pi. So the line should be like this: x by minus 2 pi plus y by plus 2 pi is equals to 1. This is minus x plus y equal to 2 pi. So y equal to, this is 2 pi plus x. Y equal to 2 pi plus x. There it is. There it is. This is the line y equal to 2 pi plus x. Y equal to 2 pi plus x. Understood? Y equal to 2 pi plus x. So very, 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 very important. Very, 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 very important. Now these are not required. Just simple draw the graph y equal to x. Draw the line like this. Draw the line like this. Draw the line like this. Check the line where the line intersects the x-axis and where the line intersects the y-axis. Both are intercepts. X by pi plus y by pi. What is this line? This line intersects the x-axis at pi and y-axis at pi. X by pi plus y by pi equal to 1. So x plus y equal to pi. X plus y equal to pi. So y equal to pi minus x. Simple. Y equal to pi minus x. So like this, we can draw the graph of sine inverse of sine x. What is the use of it, sir? How do we apply this graph to problem, sir? Let me explain. Let me explain. See, if the value of x lies in between minus pi by 2 to plus pi by 2, if the value of x lies in between minus pi by 2 to plus pi by 2, then y, what is y? Sine inverse of sine x. So sine inverse of sine x equal to x. See, if the value of x lies in between pi by 2 to 3 pi by 2, if the value of x lies in between pi by 2 to 3 pi by 2, what is the value of y? Pi minus x. What is the value of y? Sine inverse of sine x. Sine inverse of sine x equal to pi minus x. If the value of x lies in between 3 pi by 2 to 5 pi by 2, if the value of x lies in between 3 pi by 2 to 5 pi by 2, what is the value of sine inverse of sine x, sir? X minus 2 pi. X minus 2 pi. So in the examination, he may ask the question like this. In the examination, he may ask the question like this. What is the value of sine inverse of sine 5? He may ask the question like this. What is the value of sine inverse of sine 5? Sir, it is of the form sine inverse of sine x, sir. Sine cancels, sir. 5, sir, answer. No. So sine inverse of sine 5. This is very important. Here 5 means not degree, it is 5 radians. It is 5 means 5 radians. Do you know the value of 1 radian? 1 radian is approximately equal to 57 degrees, not exactly, approximately. 1 radian is equal to how much? 57 degrees. Then what is the value of 5 radians? 5 radians. 5 radians is equals to approximately 185 degrees. Isn't it? No. 5 5s are 225 to 55 degrees. Right. Not exactly, approximately. Achha. 5 5s are 250, 285, sorry, 285. 5 radians is equals to 285 degrees approximately. Achha. So now, we have to check in which region 285 lies. In between minus pi by 2 to plus pi by 2? No. It is not lie between minus 90 to plus 90. It is not lie between 90 to 270. So it lies between 270 to 540, 450, 270 to 450, 270 to 450. Achha. So in between 270 to 450, 285 is there. Achha. So here 5 radians lies in between this region. So what is the answer in that? Y equal to x minus 2 pi. So it is of the form sine inverse of sine x, sine inverse of sine x. Answer is x minus 2 pi. Answer is x minus 2 pi. So 5 radians minus 2 pi is the answer for this question. You can write the directly answer. You can write the answer directly. So sine inverse of sine 5 radians is equal to 5 minus 2 pi. Simple. Sine inverse of sine 5 radians is equal to 5 minus 2 pi. Suppose sine inverse of sine 10 is given. Sine inverse of sine 10. Sine inverse of sine 10. How do you find out the value of sine inverse of sine 10? So 10 radians is equals to 10 radians, not 10 degrees, 10 radians. Sine inverse of sine 10, he may ask the question. Sine inverse of sine 10. 10 means 10 radians. 10 radians is equal to 570 degrees. 10 radians is equal to 570 degrees. Not exactly, approximately. So 570 degrees lies in between 5 pi by 2 to next line should be like this. Next line should be like this. 5 pi by 2 to 7 pi by 2. 5 pi by 2 to 7 pi by 2. 5 pi by 2 means 450, 7 pi by 2 means 630. So definitely 570 is lies in between 5 pi by 2 to 7 pi by 2. So in between 5 pi by 2 to 7 pi by 2, the line should be like this. The line is like this. See, the line intersect the x-axis at 3 pi, y-axis at 3 pi. Plus y-axis. So the equation of this line is x by 3 pi plus y by 3 pi is equals to 1, isn't it? So that x plus y is equals to 3 pi. So what is the equation of this line? What is the equation of this line? 3 pi minus x. The equation of this line is y equal to 3 pi minus x. Y equal to 3 pi minus x. Clearly 10 radians lies in this region. So therefore sine inverse of sine 10 is 3 pi minus 10. Simple. 3 pi minus 10. Sine inverse of sine 10 is 3 pi minus 10. That is the use of this graph. That is the use of this graph. For example, you may ask the question like this. What is the value of sine inverse of sine 2 pi by 3, sir? Sine inverse of sine 2 pi by 3. So let us see. In which region 2 pi by 3 lies? It's very simple. In which region 2 pi by 3 lies? In between minus pi by 2 to plus pi by 2? No. In between pi by 2 to 3 pi by 2, definitely 2 pi is there. 90 to 270. In between 90 to 270, 120 is there. Yes, it is of the form sine inverse of sine x. Sine inverse of sine x is equal to pi minus x. Sine inverse of sine x equal to pi minus x. So the answer for this question is pi minus x means 2 pi by 3. So pi minus 2 pi by 3, it is pi by 3. What is the value of sine inverse of sine 2 pi by 3? Pi by 3. What is the value of sine inverse of sine 2 pi by 3? Pi by 3 simply. That is the use of this graph. Very important. Very, very important. So let us draw the graph of cos inverse of cos x. Graph of cos inverse of cos x. Graph of cos inverse of cos x. Zero, pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, minus 5 pi by 2, and so on, of course, minus 3 pi. So the graph of cos inverse x is always lies in between 0 to pi. 0 to pi. Why? Because cos inverse x domain. Okay. So now in between 0 to pi, cos inverse of cos x, cos inverse of cos x. So y is equals to cos inverse of cos x. So y is equal to x for all x belongs to 0 comma pi. For all x belongs to 0 comma pi. In between 0 to pi, the graph of cos inverse of cos x is y is equals to x. Y is equals to x. I'll give the trick now. Just draw the first line. Just draw the first line. So 0 to pi. Next pi to 2 pi. Pi to 2 pi. So the graph of cos inverse x lies in between 0 to pi. So the next line should be like this. Now, the next line should be like this, no doubt about it. The next line should be like this. The next line should be like this. Very simple, very simple. This is the graph of cos x. This is the graph of cos inverse of cos x. See this line? This is the line passing through horizon. This is the line y equal to x. Now this is the line passing through horizon. This is the line y equal to minus x. This is y equal to x and this is y equal to minus x. Very simple now. Acha. So this is the line. See, this line intersect the x-axis at 2 pi, y-axis at 2 pi, plus 2 pi, plus 2 pi. So what is the equation of this line? X by 2 pi plus y by 2 pi is equals to 1. So x plus y is equals to 2 pi. So then what is the equation of this line? Y equal to 2 pi minus x. So this is y equal to 2 pi minus x. Y equal to 2 pi minus x. Now let us see this line intersect the x-axis at 2 pi, y-axis at minus 2 pi, isn't it? This line intersect the x-axis at 2 pi, y-axis at minus 2 pi. So what is the equation of this line? X by 2 pi minus y by 2 pi equal to 1. X by 2 pi minus y by 2 pi equal to 1. So that x minus y is equals to 2 pi. X minus y equal to 2 pi. Then what is the value of x? What is the value of y? X minus 2 pi. So this line y is equal to x minus 2 pi. Y equal to x minus 2 pi. Let us see this line. This line intersect the x-axis at minus 2 pi, y-axis at plus 2 pi, x-axis at minus 2 pi, y-axis at plus 2 pi. So that x by minus 2 pi plus y by 2 pi is equal to 1. Y by 2 pi is equal to 1. So that minus x plus y is equal to 2 pi. Then what is the value of y? 2 pi plus x. So the line y is equal to 2 pi plus x. This is the line y equal to 2 pi plus x. Let us see this line. This line intersect the x-axis at minus 2 pi, y-axis at minus 2 pi, x-axis at minus 2 pi, y-axis at minus 2 pi. So the equation of this line is x by minus 2 pi plus y by minus 2 pi and minus y by 2 pi equal to 1. So minus x minus y equal to 2 pi. What is the value of x? What is the value of y? So y is equal to minus x minus 2 pi. Y is equal to minus x minus 2 pi, isn't it? Y is equal to minus x minus 2 pi. This line, y is equal to minus x minus 2 pi. Like this, we can draw the graph of cos inverse of cos x. We can draw the graph of cos inverse of cos x. This is the graph of cos inverse of cos x. Then what is the use of this one, sir? Let me explain. So let us see what is the value of, so we made the question, cos inverse of cos 7 pi by 6. What is the value of this, sir? He may ask the question like this: what is the value of cos inverse of cos 7 pi by 6, sir? So let me explain. 7 pi by 6, it means 7 into 30, 210 degrees. So 210 degrees lies in this interval. 210 degrees lies in more than 180, less than 360. So this interval. So in this interval, y is equal to 2 pi minus x. Y is equal to 2 pi minus x. So cos inverse of cos x, cos inverse of cos x is 2 pi minus x. It is 2 pi minus, here x means 7 pi by 6. See how easy it is. So it is 12 pi minus, it is 5 pi by 6. The value of cos inverse of cos 7 pi by 6 is 5 pi by 6. Simple. Very simple. Cos inverse of cos 7 pi by 6 is 5 pi by 6. That is the answer for this question. Suppose he may ask the question like this: what is the value of cos inverse of cos 5, sir? Cos inverse of cos 5. So 5 means 5 radians. 5 means 5 radians. 5 radians is equal to 285 degrees. 5 radians is equal to 285 degrees. Definitely 285 degrees lies in between 180 to 360. Pi to 2 pi. So what is the value of cos inverse of cos x, sir, in this region? 2 pi minus x. What is the value of cos inverse of cos 5, sir? 2 pi minus 5, sir. Very simple. Very simple. Very simple. Suppose he is asking cos inverse of cos 10. What is the value of cos inverse of cos 10, sir? Cos inverse of cos 10. 10 means 560 degrees. 10 means 570 degrees, of course, 570. So 570 is less than, 570 is less in between 3 pi to 4 pi. 3 pi to 4 pi. In between 3 pi to 4 pi, the graph lies like this, right? Graph like this. So the next line meets the x-axis at 4 pi and y-axis at 4 pi. So the next line meet the x-axis at 4 pi and y-axis at 4 pi. The next line may be x plus y is equal to 4 pi. So y is equal to 4 pi minus x. Y is equal to 4 pi minus x. So clearly 10 radians is lies after 540. After 540. So 542 and something next 4 pi. So 3 pi to 4 pi. So 10 radians is lies in between 3 pi to 4 pi. In between 3 pi to 4 pi, y equal to 4 pi minus x. So cos inverse of cos 10 is 4 pi minus 10. Cos inverse of cos 10 is 4 pi minus 10. Cos inverse of cos 5 is 2 pi minus 5. That is the use of graphs. Very important in inverse trigonometric function. Very important. Very important. Clear? So in the next class, we are going to discuss about the graphs of tan inverse x, cot inverse x, secant inverse x, cosecant inverse x. Don't miss the next videos. Watch the videos completely. It very is useful for you, useful to you. Okay. If you like my videos, don't forget to subscribe. Okay. Thank you. We'll meet in the next video.